Good morning, dear students. Today we will solve some important example of pointwise convergence sequence, pointwise convergence of a sequence. Okay. Uh, for example, the question is fn x equal to nx upon 1 plus n square x square, 1 plus nx, where x belongs to the real number and n is greater than equal to 1. Okay, in this case, for finding the pointwise convergence of this sequence, we have we can check the limit of this function f x equal to limit x tends to infinity n x upon 1 plus n square x square on n square x. If the limit exists, then this function is pointwise convergence. And if limit does not exist, then this is not pointwise convergence. This is a one method. This is the first method for finding the pointwise convergence of this sequence. It is equal to limit x tends to infinity and x upon we can take common n square x square. This is, and this value is 1 upon n square x square, n square x plus 1, and it is equal to, when n tends to infinity, we can cancel out this, and x tends to infinity. When x tends to infinity, then 1 upon x equal to 0, and this value and n is also tends to infinity. Limit x tends to infinity, 1 upon n and 1 upon n square x plus 1. When x tends to infinity, then it is equal to 1 upon n. Now, the 1 upon n is greater than equal to 0. So when we put n equal to 1, then this is 1, 2, then this is 1 upon 2, 1 upon 3, 1 upon 4, and so on. It means this tends to 0 for every n, and where n greater than equal to 0, and this limit is exist. It means the function is pointwise, the set of this function is pointwise convergent. And another method is, suppose that when you put at the place of n f1x, when you put 1 at the place of n, then this is x upon 1 plus x. When you put 2, then this is x upon 1 upon 2x upon 1 upon 4x. Similarly, when you put 3 and x belongs to the real number, it means for every real number, every function f1, f2, f3 and so on, the limit of every function for every real number must be exist. And in this case, the limit x tends to infinity, the f1x is 1 upon 1 upon x, it is equal to limit x tends to infinity, x upon x is common, 1 upon x plus 1, and 1 upon infinity is 0, and limit is 1. Similarly, for second case, limit x tends to infinity, 2x upon 4x is common, and this is 1 upon 4x plus 1. We can cancel out this, and this is infinity, this is 1 upon 2. Okay, it means every function exists, every function has a limit point, every function has a limit at every point in the real line. Okay, and The convergence of every function tends to a particular real number in the real line. It means this function is pointwise convergent. Okay. And similarly, we can solve another function and we can verify the pointwise convergence of another function. Fn x equal to, this is x upon 1 plus nx, where x belongs to the closed interval 0 and 1. This is question number first. Student, you can solve this question with the help of this example. Second example is fn x equal to n square x upon 1 plus n cube x cube. X belongs to the closed interval 0 and 1. Okay, and in both case n is greater than or equal to 1. Okay, so these are two examples for understanding of the pointwise convergence of a sequence. Okay, sequence of function. Okay, just then solve these example with the help of this example and find the pointwise convergence of this example. Okay, thank you.